I'm very glad today to be speaking with a special guest, one of the world's leading conservation biologists, Professor Thomas Lovejoy. Professor Lovejoy has worked in the Brazilian Amazon since 1965, where he established one of the planet's largest and most important landscape ecology research projects. He popularized the term biological diversity, which is now widely used to describe the variety of all Earth's living organisms and ecosystems. At this time, Tom was part of the group of scientists who helped establish a new scientific discipline of conservation biology. He has advised 4 US presidential administrations on matters of biodiversity and conservation, and holds many other influential positions. His work has been widely commended with numerous awards, including the Blue Planet Prize in 2012. So welcome again, Tom, and thank you so much.
Well, great to be with you, Joey.
And I came across this title of yours, which I really like in particular. National Geographic calls you an explorer at large, which fits pretty well, I think.
Well, it's pretty exciting, actually. There are only 8 people in the world who get that. So,
wow. Although this year hasn't been such a good year for exploring, many people confined to their homes. Have you been able to enjoy the nature around you? And do you think other people have been doing that more this year?
No, actually, it's quite wonderful. So I'm right next door to 300 acres of forest. So I've been able to enjoy nature day by day, which I've never actually been able to do anywhere because I've never sat still long enough. So it's great. And now we see the end of summer and rolling up and autumn starting, and birds are migrating south. So it's sort of cool.
Yeah. Yeah, I think it's the same for a lot of people, that there's been this resurgence in bird watching, for example. People are appreciating parts of the world that can come to them, being restricted to their homes. What are some of the plants and animals that you see around your home?
So we have pretty good variety here. I've never seen it right here, but immediately next door, and not very far away from that either, we've had juvenile black bear, exploring, once they've been kicked out of the mother's care. So we have a pretty good variety of birds. We have North America's largest woodpecker, the pileated woodpecker. Normally not so easy to see. You hear them, and you hear them making, drumming and looking for goodies in dead wood. But they actually came and joined me one evening when I was having a glass of wine, utterly oblivious to me. It was great.
Yeah, fantastic.
And then just 3 days ago, a tiny little snake, smaller than even a shoelace, actually showed up in the house. And I know what it was. It's called a ringneck snake because it has a little ring, right? Beautiful little thing. It's the smallest one I'd ever seen. How it got in, I don't know, but I escorted it back outside.
Yes, we've had some of our sanctuary staff reporting lots of snakes inside up on Cape York. But Tom, your field work at least, started in the Amazon in the 1960s. And at that point, the forest was largely intact. Can you give us a sense of the scale of that vast forest and what it was like to start working in that landscape?
Yeah, so 1965, the Amazon was 97% intact. And to give you that sense of scale, it's roughly equivalent to the 48 contiguous United States. Looks much smaller on the map because of the Mercator projection, which exaggerates everything away from the equator. But it's vast. And, on the eastern end is the tropical Atlantic, and on the western end are the Andes. And one of the amazing things that it actually does is make half of its own rainfall, which was discovered in the mid-1970s, shattering the paradigm which said that vegetation is simply the consequence of climate. It has no effect on it whatsoever. Literally in the Amazon, the water is recycled 5 or 6 times. The air mass moves to the Andes, and then, of course, it then rises, right? Gets cooler, and all that moisture drops out and creates the 20% of the world's river water, which is the Amazon. So basically, when I got there, it was a biologist's dream. Much of it unknown, much of it still unknown, and always an opportunity, get a wonderful surprise and see something completely new.
Yeah, and that must have been so different to, North American landscapes that you were familiar with. What are some of the animals that you encounter working in the Amazon that are, distinctly South American?
Well, when you first walk in the Amazon forest, you think, what's the big deal? Because all you see are all these trees and everything is green, and everything's hiding from everything else. But you begin to develop an eye for it. And first you see the small things, tons of insects and butterflies and things like that. And you hear lots of birds, you just don't see them too easily. But in my favorite of my research camps, it's basically intact primeval forest from there all the way to the Guyanas, and there's jaguar that see us. We never see the jaguar, or maybe 2 or 3 times in 30 years, right? We see its footprints a lot. It knows what we're doing. And now we've had tapir show up in camp. Happily not white-collared peccaries, which can be pretty fierce when they're in a group. And all kinds of gorgeous birds, including the harpy eagle, which is nesting like 200 meters from camp. Probably been there long before we discovered it because it's so quiet. And that's the most powerful bird of prey in the world. And it basically preys mostly on monkeys and sloths. The monkeys, it gets by literally punching them out with its claws all rolled up into the equivalent of a fist. So it punches out the monkey. All of this is going on in the canopy of the forest. And the monkey, of course, falls to the ground, and then the harpy eagle is there in a minute and dispatches it with its talons. The sloth, however, is a different matter. So when they tackle a sloth, usually the sloths are hanging on for dear life to the branch on which they're clinging. And very often the harpy eagle takes the branch along with the sloth. It's quite an amazing bird. I would not want to be, in an altercation with one.
Yeah. Wow. That's fantastic to have that going on right around you. And I've got a picture of you from that Camp 41, which you described. This is now a really long-running research program that you helped establish in the Amazon. I guess for most of us, we think of the Amazon, and what is famous about it is how quickly it's being lost, and the fragmentation and decay of that rainforest, which is quite horrifying, as an outsider. But you saw an opportunity in that fragmentation to find something out about biology and about how ecosystems work. Can you talk to us about the big questions that you've been asking through your research in the Amazon?
So the really interesting thing is that fragmentation was not considered a conservation issue until like 1970. And that's because the consequences of fragmentation play out over time. So instead of, you know, like a big jump off a cliff, it happens relatively gradually, and nobody's there sort of watching it. And so I had just joined the staff of the World Wildlife Fund US, and I realized that unless we understood all of that a lot better, we actually didn't know whether any of our conservation projects would be successful. And I happened to have had enough experience in Brazil to remember that they then had a rule that said 50% of any project in the Amazon had to remain in forest. So the crazy idea, which actually worked, was maybe you could persuade the Brazilians to arrange the 50% to create a giant experiment where you could study the fragments to be while they're still part of continuous forest, and then watch them change once they're isolated fragments, and also have the ability to look at what was happening in matching plots in continuous forest, just in case some of the things you were seeing in the fragments also was happening in continuous forest, in which case the causation would be separate.
Yeah, that's you know, I guess that's an interesting policy in that it means that some of the forest is protected, but it's, you know, you're still watching the loss of large parts of it. But as you said, the information that we can gain from understanding how those fragments change over time has become really, really useful. How does that tie in with the ideas of island biogeography? And how did that help with the foundation of conservation biology?
So island biogeography was actually the reason that people started to wonder about fragmentation. You know, as a piece of ecology which is trying to explain why different islands had different numbers of species on it. And then somebody made the leap that maybe that would apply to islands of habitat created by deforestation or whatever. And so I owe a lot to island biogeography without any question. And just recently, we did a new analysis of the data. And if you look at the forest interior bird species that occur in 10-hectare fragments, they are uniformly a distinct subset of the forest interior bird species in the 100-hectare fragments, which in turn, of course, are a subset of what's in the continuous forest. So it's highly ordered structure in those forests, which is responding in a very measured way to habitat fragmentation.
A lot of this research, as you've said, has been carried out at Camp 41, and that's become this base for scientists right in the rainforest, in the jungle. I just was interested in what you think about how important it is to have scientists with the facilities in remote places like that to carry out that work. As you know, that's a big part of AWC's approach, is getting scientists and land managers on the ground.
And so if you don't have places like AWC has, or places like Camp 41, basically you're just sampling. It's almost, it would be unfair to call it a dilettante approach to science, but it's not systematic in the way that long-term studies of particular places can reveal what's actually going on. And I also have to say, I inadvertently discovered that Camp 41 was a great place to take these mythical beasts called decision makers and let them live the life of the forest, sleep in hammocks, um, but listen to the forest all day long and all day night. And after 3 days of doing that, there has been nobody who doesn't come away understanding that is a living planet that we're on, and we need to manage it that way and with much greater respect than we are doing at the moment.
Tom, you've been a founding member of AWC's Science Advisory Network, a group of scientists that helps drive our science strategy and make decisions about prioritizing different projects. And over the last few years, you've visited a lot of our sanctuaries, almost one a year for the time I've been involved. And I've got some pictures from your visit to New Haven. This was, I think, about 4 years ago. Sampling some of the biodiversity there. These are honeypot ants, which you said you were
honeypot ants, yeah,
familiar with before you actually arrived.
And the witchetty grubs.
Yeah, I've got a photo of them too, but these taste much nicer.
So you had to have dessert. There was dessert. And that's the witchetty grub. That's the witchetty grub. I did it. Wasn't bad, actually.
I remember that there was a plate full of witchetty grubs and the biggest, fattest one was left to me, which wasn't as well cooked as the others. At New Haven, we work really closely with the Indigenous people there, the Walpri, and you met Alice and Christine, who have helped immensely with getting that project established, the large cat-free fenced area. I'm interested, have you worked with Indigenous people in the Amazon, and are there shared experiences there or different perspectives that you've learned from?
Well, I certainly engaged with Indigenous people in the Amazon, never on an extended basis. But they are, they're nothing less than extraordinary in terms of what they know about and understand about where they live. And I don't think there's any question that there once were really very extensive indigenous populations in the Amazon, probably more along the rivers than in between, just because the rivers are important for transport and for fish protein. But they were able to be extremely successful in what 100 years ago looked like impenetrable forests, because their numbers, dropped precipitously once European diseases arrived. So much so that people had forgotten that there had been large numbers. If you actually go back and read about the first expedition down the Amazon, which started out in Quito and went up over the Andes and down into the Amazon, not intending to go all the way, but they did go all the way. And there was a friar who kept sort of the records of the trip, and who also survived an arrow through the eye. But he clearly describes large indigenous populations and never being essentially out of sight of one.
That's really interesting. Also at New Haven, we came across, well, lots of different animals, but one was this little lizard called a thorny devil. And
oh, that was so amazing. That was so amazing.
Fascinating lizards. They can drink using capillary action. So, they plonk their foot in a puddle and the water moves up on special grooves on the surface of their skin into the corner of their mouth.
It is absolutely amazing. I mean, I watched that, one of those and put down in essentially a very small puddle, and within 2 or 3 minutes, the puddle was gone.
Mm. And, Australia is incredibly diverse, especially for reptiles. I think we're the most diverse country in the world for lizards, for example. Just wondering from an international perspective, how do you see Australia as a global player in terms of biodiversity?
So, Australia is this miraculous place where somebody comes from outside like me and everything you look at is different. Truly exciting. Uh, but it's also, there are, it's a tiny number of countries in the world which can go down as really great stewards of nature in their time, like Bhutan. Um, so there was a lot of destruction in Australia as people tamed the land, never deliberately intending to be destructive of nature, uh, but just sort of thinking it could take whatever you dished out to it. Uh, and in particular, the introduction of exotic species like cats and rabbits and foxes uh, and cane toads. And they take an enormous toll of the Australian fauna and probably indirectly some of the flora as well, because the native fauna just simply has had no evolutionary history to develop ways to resist these interlopers from afar. Uh, and one of my most amazing uh, experiences visiting AWC properties was the one that's in far western New South Wales.
Yes,
That
Scotia Sanctuary.
Scotia. Um, and going inside the exclosure during the day, and the ground is just totally different from outside. Outside, it's just, almost like pavement. You go inside, and there are holes all over the place, obviously created mostly by mammals. And then you get a chance to go in there at night, and the ground is literally, because you're in Australia, and the mammals are, so many of them are marsupials, the ground is literally hopping. This is like Australia really was 200 or 300 years ago. So it provides a very useful standard to understand the impacts on other parts of the landscape and hopefully inspire similar kinds of conservation initiatives as you have at Scotia or New Haven.
Yeah, I'd like to come back to those kind of fauna reconstruction projects that we have underway. I should say this isn't a giant burrow from a marsupial. It's actually the nesting mound from the malleefowl, which we visited while you were there. So I didn't want to give the wrong idea there, but yeah, that's one of those ground nesting birds, the megapodes.
Well, the whole family is amazing. None of them incubate their own eggs. Many of them, like the malleefowl, use rotting vegetation to provide the heat to incubate the eggs. But I actually visited one in New Britain, which basically nested in burrows alongside volcanic streams. So, you couldn't even stick your finger in the stream. You would been scalded in an instant. And so they built their nests and burrows and used the volcanic heat, to incubate their eggs. Just amazing adaptation.
Yeah, it's a wonderful family of birds. You've also visited Pangalina up in the Gulf, and I think this certainly feels like one of the more remote AWC properties. It's about a 3-day drive from Darwin, the capital of the Northern Territory, and it includes the only destocked section of that part of the coast, the Gulf of Carpentaria, and a really interesting diversity of ecosystems, mangrove-lined inlets, dune systems, acacia woodlands, and then lots of different eucalypt woodlands as you head further back from the coast. And I think, you're saying how important it is that Australia still has these large wild landscapes, which, apart from being spectacular, also support such a great diversity of wildlife. And as part of that trip, I remember we found a gecko, and this was a species which had only just been described to science. It's a type of velvet gecko. And I'm just interested, Tom, in, we're splitting these gecko species, deciding what constitutes a separate population which should be recognized as a species. Why does that matter? Why do you think it matters that we're informed about diversity? Why does it matter to recognize that particular species as separate?
Well, I think the important way to look at it is that all that biological diversity is, in essence, it's a gigantic library, living library for the life sciences. And each species every day is in the process of inventing new solutions to new biological challenges in its existence. And eventually that often produces sufficient difference to have a distinct species. So understanding how things come into existence and how they maintain their ecological separation from other species is an incredibly information-rich exercise. Fascinating in itself, but often sometimes extremely valuable in terms of scientific application. Yeah.
And there are different answers to that. And I had John Wojnarski, a well-known Australian ecologist, on last week, and just asking about what is the value of a species. And I guess the corollary of that is, what do we lose when a species goes extinct? And I think it's not enough just to talk about the services that they provide us, but looking at it as part of a whole, part of a living system, is another important way of seeing it.
Yeah, so my own take on all of that is that every living creature on Earth is actually part of like a 4 billion line of evolution. And to terminate one of those is knowingly or carelessly, it's really a terrible thing to do. They've been around as long as we have. And when we were at Pangalina, remember we went out on the 1.5-billion-year-old seafloor?
Yeah.
And it was covered with these fossils called stromatolites. There they are, which were formed by essentially the earliest organisms on Earth, the blue-green bacteria. They dominated the Earth. And they oxygenated the atmosphere. We wouldn't be here without the stromatolites, right? So I got permission to take one of them home as a teaching tool. And then 3 or 4 weeks later, I had to make some remarks at the 100th anniversary of the Ecological Society of America. And the other shoe dropped. And I realized that for the blue-green bacteria, oxygen was a toxic waste substance. And they filled up the atmosphere with it and made themselves scarce. Now, does that sound familiar?
It sure does. And that's a bit of a worry if that's,
So I use that at the beginning of my course, Challenges in Biodiversity, every year, part of lecture number 1.
Fantastic. So AWC is still part of your teaching over in the States?
Very much so.
Excellent. And I'm interested in that interaction between biodiversity and climate, which is, essentially the stromatolites are a good illustration of that. And you've recently literally written the book on climate and biodiversity. What were the big lessons from pulling together all of that information?
So I actually did 3 books, the first in 1992, the second in 2005, and the one you're referring to in 2019. And by the time we get to 2019, there's not a place on the surface of the planet where you can't see the imprint of climate change on living things. And we're also seeing them stress entire ecosystems. Because the way climate change works with ecosystems is it will sort of zoom in on a particular little bit of natural history and affect that. So in tropical coral reefs, it's the relationship between coral animals and the alga, which is the fundamental basis for the entire ecosystem. So we're seeing essentially ecosystem failure, the great bleaching events. Similarly, in North America, we're seeing our western coniferous forests basically have their balance thrown in favor of the native bark beetles, which get in more generations. And so there are places where 70% of those trees are dead. And the more one looks at all of this and understands that with greater climate change, ecosystems actually begin to come apart. One comes to understand that the biology of the planet is more sensitive to climate change than most anything else that's important to us. So if we want a biologically manageable planet with all this incredible biological diversity that we're actually looking at on the screen here, I believe we need to limit climate change to 1.5 degrees. And the truth is that we are way beyond the CO2 levels in the atmosphere that would enable us to stop at 1.5 degrees. And so you might ask, is it all over? You know, I mean, should I just go off with a good bottle of Australian red wine and never be seen again, right? But the really important and exciting thing is that biology can get us out of this mess we're in. And we now know that the amount of carbon dioxide in the atmosphere from destroyed terrestrial nature is roughly equal to what remains in extant terrestrial nature. I'm the only person so far that's putting it that way, but that's what the numbers are. And it's pretty shocking that we've destroyed half of terrestrial nature. But the good news embedded in that is ecosystem restoration at scale, aimed at pulling about 1/3 of that CO2 back out of the atmosphere, could enable us to get to a soft landing at 1.5 degrees. So basically, we need to really stop and recognize that the planet works as a combined biological and physical system, that a healthy nature is in not only other species' interests, it's in our interest. And that everybody can make a difference in all of that by planting a tree or helping, shovel some mud for restoring a wetland or restoring degraded grazing land. And whenever you do that, you get benefits in any case. We should be doing that just for those benefits, but we get that atmospheric benefit as well.
Yeah, and that's an excellent answer. Thank you. I think that really brings us to the point that the loss of biodiversity is not just a hobby to be concerned about. It's actually dangerous to human civilization, and that extinction concerns all of us, or it should do.
I mean, keep going the way we're going, and it will lead to a seriously impoverished future for humanity.
You mentioned, though, that restoring ecosystems, rebuilding populations of species is really the best way out of this. And you've seen projects like you talked about at Scotia, AWC projects where we are rebuilding those ecosystems and the processes that have evolved within those ecosystems over millions of years. You also visited New Haven, where we're undertaking a massive restoration of locally extinct mammals. Have you seen any projects around the world that compare in ambition or scale to the kind of projects that AWC is undertaking?
So if I stop and think about it, I surely have seen ones that are similar in scale. If you measure it in acres or hectares or whatever. But because of the vulnerability of Australia's fauna and flora to exotic introduced species, it's a much tougher game in Australia. And people's memory sort of fades, and they forget how things used to be, and then begin to accept the way things are as the way they should be. And that's one of the great values of the AWC exposure experiments, because it shows what you can actually do. So, I think they're quite wonderful and remarkable, and I've enjoyed every visit I've ever had.
We hope it won't be too long before your next visit, but we'll have to wait and see.
Yeah, both COVID willing, right?
Yeah, that's right. Yeah, we're all in that situation at the moment. I'm interested, Tom, in what you see as kind of the recipe for effective conservation. Are there things that good conservation projects have in common, around the world when you're assessing these things?
So most good conservation projects around the world depend on good science and people who really care, and various forms of that. But that's what it comes down to. What needs to happen is for people to understand that nature is actually the basis for our well-being and our future well-being, and that we need to embrace it, to nurture it, and to enjoy it. And it's really interesting. It's probably happening in Australia too, but with so much of the U.S. on lockdown, the visitation to natural areas just shot up. One, because there's not a lot of other alternatives. You can't go to movies or, distract yourself that way. And so I think a lot of people rediscovered nature in the process, and hopefully that will stick with them when they don't have to run around with masks on anymore.
Well, thank you very much for the conversation today, Tom. I'll see if we get some questions in. I guess just to finish up, I'd like to ask, what gives you hope? What are the inspirations for you to keep continuing the work that you're doing? What gives you optimism about the future?
Well, there are two or three things. One is seeing so many young people interested and caring about all of this and wanting to make their careers in protecting the environment, and particularly the natural part of the environment. Because without that, we'd never get anywhere. And it's also, if you actually look back, you actually notice there's been a lot more progress than maybe you realize. We were all into the latest struggles with governments that are being pushed by short-sighted people to do less for nature and less for the environment. But if you look around the world, even though these struggles go on, the amount of protected area that's been created in the last 20 or 30 years is astounding. And, you know, my favorite example, of course, is the Amazon, which when I started in 1965, had one national park and one demarcated indigenous area, and that was it. And I remind you, that's for 48, the equivalent of the 48 contiguous US states and area. Today, half of that is under protection. 1/4 is in demarcated indigenous reserves, with the indigenous people taking really good care of them. And the other half are in more traditional conservation areas. So if you think about it, you know, that 30 years ago, most of that didn't exist. It shows you really can make a difference. And so it's important occasionally to lift one's head up from whatever the struggle is of the moment, and just look over your shoulder and see the progress that has taken place.
I think that's incredibly important. We've had a couple of questions in here from the audience. An interesting one here, you know, AWC's focus has been largely on landscapes which are unmodified, but recently we've established new partnerships with pastoralists, with government on different tenure. And this question is asking about conservation outside of reserve areas. So, you know, sustainable agriculture, improving protection of biodiversity on land which is not dedicated to conservation. Your comment on that, Tom?
So if one really hopes to have a reasonable, and I would say an ambitious amount of biological diversity, making it into the next century and beyond, what happens outside of strict protected areas is as much a part of achieving that as what goes on inside. And particularly the whole food and land use trajectory on the planet needs some major modification so that it is less destructive of nature, let's put it simply. And one of the really interesting things is scientists have looked at how you can feed 8 billion people and maybe a couple billion more, and analyzed it and figured out you can actually feed them reasonably well without destroying another square inch of nature. And that just involves thinking more carefully about how we practice agriculture, realizing how important it is to have riparian vegetation to prevent soil loss and problems with aquatic ecosystems. It's also a matter of food waste. We waste an awful lot of food that doesn't need to be wasted. And of course, there are improvements to productivity that we can pull off judiciously here and there without bad side effects. And then the third thing, of course, is adjusting our diet. So we're paying more attention to our doctors. And what fascinates me, being as old as I am, is that I actually grew up in Midtown Manhattan with parents who'd been through rationing in the Second World War and had been through similar tight times in the Great Depression. And they just had a basic in sort of inherent frugality. And in those days, even if you could afford it, you would have thought about having beef more than once a week. Um, and so if we start paying attention to our doctors and adopting some of that frugality, I think we can basically have a much better trajectory for the future of humanity and for the rest of nature.
A slightly related question here about the health consequences of not protecting biodiversity. I mean, the pandemic recently has been linked to destruction of habitat in some cases. What do you think about that?
Well, there's absolutely no question about that. I actually, when I started in the Amazon, before I did the fragments work, I was studying birds down near the mouth of the Amazon, not only for their basic ecology, but also to understand how they might relate to uh, various arthropod-borne viruses like Eastern equine encephalitis and a whole bunch of others. Um, so it's very clear to me that in nature, there are pathogens that normally circulate in wild things. Uh, and there's no better recipe to raise the probability of one of those spilling over into human populations than to keep battering away at remaining nature and uh, having a wildlife trade that is basically out of control around the world in the wildlife markets. And there's one other piece to it, which is our very large domestic animal populations create an additional magnifier uh, of the epidemiology of things that are in nature anyway. Uh, so we need to back off, is what I'm really saying, and lower the probability. We'll never get it to zero, but we certainly can lower it and be more organized and thoughtful about all those things.
Let's hope that this year is a bit of a wake-up call on that front.
Yeah, so there's a second answer to that, if I may plunge ahead, which is earlier I was referring to biodiversity as a gigantic living library. So out of that library has come vaccination, has come antibiotics, has come the ACE inhibitors, which hundreds of millions of people around the world use to control their blood pressure. And all three of those discoveries were serendipitous. Nobody was out looking at the fear to loss to try and solve the blood pressure problems of the world. Edward Jenner just happened to notice that cowpox virus seemed to protect milkmaids against smallpox, right? And Fleming was sort of irritated probably when he first noticed that there was these molds in his bacterial petri dishes that were inhibiting the growth of his bacteria. So all of those were totally accidental, and they came directly from nature. And how one could even calculate the benefit over time to humanity is beyond me, but it's just staggering.
Thank you. Another question here about, we've talked a bit about restoring ecosystems to combat climate change, but the timescales involved can be long. Forests take a long time to grow. We know that older forests store and soak up more carbon than younger ones. Do you think it's achievable in the time frame? If we pulled out all the stops and reforested large areas, do you think that's enough?
So basically, the short answer is yes, but that doesn't mean that it's going to be easy. It's going to have to be ambitious. But, you know, step number one is let's not tear down any more carbon dense habitats like tropical rainforests. Um, and then let's look all over the world for ways that we can do ecosystem restoration. And when you do it, you get all these other benefits. There's just about to be a new report coming out, commissioned by the UK Treasury on the economics of biodiversity, intended to be a parallel to the Stern report on climate change. And it's basically going to make the point, if we even did a halfway decent job of recognizing the ecosystem service values of nature, it would change the whole exercise in a very positive way.
Definitely the way to go. Well, I think that brings us to the end of most of our questions here. Actually, there's one more here. On a local level, we can get out and rehabilitate green spaces or wetlands, like you were saying. We can make decisions as consumers. We can educate our children. What do you think are the most effective things we can do as individuals?
So I'm really delighted by that question, because one of the things that ecosystem restoration offers is the ability of everybody to do something. It's no longer is this gigantic problem, what can I possibly do? Everybody can make a difference. And so the details will depend on where you live, and what areas would be most suitable to restoration. And so I don't want to be prescriptive about it. I mean, obviously, we're not going to turn downtown Sydney into a forest. But
except at North Head, where we've reintroduced 3 mammals within Sydney Harbour.
Yeah, well, that's true. That's true. So, but there will be parts of that city which will remain in concrete. Let's put it that way. But and that's a good point. Is anywhere you look, there's something you can do. And I would encourage everybody to just wake up tomorrow morning and think about that, and start engaging, other people about ecosystem restoration, and reminding people that the planet actually works as a linked physical and biological system. And it's about time that we embrace that rather than let it squish us, or let ourselves squish us, right?
I think that's a good note to finish on. Tom, thank you for your service on AWC's Science Advisory Network. We hope to see you again soon at a sanctuary, and thank you for speaking with us today.
Well, always great to be with you, Joey, and with AWC. So thank you.
Pleasure. Thank you to our audience today. Next week, we have a conversation with Felicity Lotelier, Flick, who some of you may have met at Scotia. Flick is now working at Mount Zero Taravale in North Queensland, where we're planning to reintroduce the northern bettong into a special fenced area there. So Flick will be along to tell us all about that project. So I'll speak to you next week. Thank you very much.